Welcome to EDU World Space.
All right, so we're looking at this sphere that lies within this little weird cylinder here. The first thing that we notice is we can write the sphere as such. After that, we're going to have to plug this into the surface area formula down here. So we're going to need Zx and Zy. So it's pretty easy to see that Zx and Zy are going to be exactly the same minus the x and y respectively. So when we take the partial derivative of z with respect to x, we get this guy here. But notice that this guy here is exactly z. So that's why I've written it like this for x and y. All right, plugging that in, we get that. Next thing that we want to do is we want to figure out our bounds for r, because we're eventually gonna want to put this into polar coordinates, as we'll see on the next slide. So we change these guys to polar coordinates. See that our radius, or our r, is just a circle centered at a on the x-axis. So we got this guy here. So we can see that this varies between negative pi over 2 and pi over 2, like so. So pardon this business here. This is I'm so used to writing 2 pi, but it's pi over 2, negative pi over 2, negative pi over 2, and pi over 2. Next, what we do is we have to do a little bit of algebra, and it'll be a little sneaky. We can see that the integrand from slide 1 can be written as such. And we know that this guy in here is a squared. The square root of that is just a, and then z squared can be written in polar coordinates as such. We did this on the previous slide as well. So this is our integral. Setting it up, doing a u sub over here, doing all that good stuff. We have to do some bounds changing, but nothing that we can't do because this is calculus 3 and not calculus 1 or 2. The only thing that's kind of to be careful of is that the square root of something squared is actually the absolute value of that. Okay, this is where the problem, you kind of have to remember back to some algebra stuff. So we get this, and remember this can be written as sine, absolute value of sine is equal to sine and negative sine theta for different values of theta, okay? And what we see is that we really have an even function here. Okay, so if you just add another slide. If you looked at sine, okay, this is sine theta between negative pi over 2 and pi over 2. And then you looked at absolute value of that, we'd have these two humps. And this thing is an even function. Okay? So the integral over negative pi over 2 to pi over 2 of absolute value of sine of pi, or sine of theta, is 2 times integral from 0 to 2 pi of just sine of theta. Okay? So that's what's going on over here, from this slide to this slide. You see the 0 and the 0 and the 2, and then our integrand is just changing to sine. And then this is just a simple integration. Okay, very simple integration. We integrate, and we end up with our answer.